So in this session we will learn how to interface DHT22 temperature and humidity sensor with STM32 Nucleo and program it in STM32 CubeIDE using Hall libraries. Let's get into the session. So coming to this, the DHT22 is an inexpensive sensor which measures relative humidity and temperature. It provides a calibrated digital output with a one-wire protocol. It measures temperature and humidity with higher accuracy and supports a wider range as compared to DHT11. So DHT sensor are pre-calibrated actually. We can directly connect them with our STM32 board to obtain sensor output readings. So they are internally composed of a humidity sensing sensor and a thermistor. So these two components measure humidity and temperature respectively. And coming to its pinout, this image shows the pinout diagram of DHT sensor. So DHT sensor consists of 4 pins. But on DHT module, only 3 pins are exposed to the pinout of the module. And the 10K ohm pull-up resistor is internally connected to the pin 2. Okay. So the following list of the pinout of the DHT sensor and a brief description. Pin number start from left to right when you hold the sensor from the front end. So it shows how these pins will be connected with the STM32 Nucleo board. BCC is the power supply pin and data pin. It is the digital output pin. It sends out the value of measured temperature and humidity in the form of serial data, and NC is nothing but this is not connected, okay, and then ground pin. So here I provide the connection details over here. So DHT sensor with Nucleo pin, power pin, data pin and the ground pin. So this is not connected pin, you can leave it. If you buy this sensor in the module format, in the sense you will not have this not connected pin, it will only have 3 pin, okay. And then to showing the output in the display, we are using OLED display. The connection is the same and the libraries are also same. So here I provide the reference picture over here, you can refer it. And now we can move for our ID. Let me create a new project. STM32 F446 RET6. System core or CC, crystal ceramic resonator, timer 1, clock sources, internal clock, go to parameter setting, pre-scalar as 71, and then here I am going to take PB14 pin as output pin, and then go for connectivity I2C1 which is for OLED, and speed mode as fast mode, and then go to clock config, HSE, PLL clock, this to 8 and this to 72, hit enter and save this to generate the code. So as usual, go and paste the libraries, okay, and over here I am going to include the library that we need. So include fonts.h library, include ssd1306.h library, and then include standard input output.h library, okay. And after all these initialization, inside this you can define DHT22 underscore port GPIO B, define DHT22 underscore pin as GPIO pin. We have taken 14th pin, right? And after this I am going to initialize some variable. Unsigned integer 8 underscore t, humidity 1 comma humidity 2, and then temperature Celsius 1, temperature Celsius 2, and then some variable, and then check variable, and then unsigned integer 32 underscore t, millisecond. Now float type temp Celsius, I am going to initialize this with 0, and then again float temp Fahrenheit, I am going to initialize this with 0, and then float humidity, this is also I am going to initialize this with 0, and again unsigned integer 8 underscore t, here for humidity, integral decimal temp f underscore integral decimal, okay, and then character string, that's 15 is enough, okay. And then after this I am going to give a void micro delay function. So inside I am going to pass unsigned integer 16 underscore t delay, and inside this hall timer set counter h timer 1 comma 0, okay. Inside while hall underscore timer get counter address of h timer 1 less than delay, that's it, okay. So here we have the micro delay function where we set the timer counter register value on run timer 0. So it continues to run while the timer counter register value, which is a single parameter of this function, remains less than the delay, okay. And after this, see unsigned integer 8 underscore t DHT22 start. So inside I am going to pass while. So inside this function unsigned integer 8 underscore t response, I am going to initialize this with 0, and then GPIO underscore init type def GPIO init structure private, I am going to initialize this with 0, okay. GPIO underscore init structure private, okay, dot pin, which is equal to DHT22 underscore pin. Again the same thing, GPIO underscore initialization structure private dot mode, which is equal to GPIO underscore mode underscore output underscore pp, okay. Now GPIO init struct private dot speed, which is equal to GPIO speed frequency low, and then so here let me clear with it. GPIO underscore initialization struct private dot pin, it is equal to DHT32 underscore pin. Okay, and after this I mentioned the same thing. Okay, now mode here GPIO underscore mode underscore output underscore PP. Okay, so now GPIO underscore private dot pin mode speed, and now I am going to give pull. Okay, equal to GPIO no pull. Okay, so inside this function we will first define the GPIO initialization structure. So this includes the pin, mode and enabling pull-up resistor. So we are configuring DHT32 pin, GPIO pin in, GPIO mode output PP operating mode, and the speed of the selected pin as GPIO speed frequency low, and no pull-up activation is specified on the selected pin. And after this call GPIO init, which means initialization inside DHT22 port comma address of GPIO init struct private. After this call GPIO write pin DHT22 underscore port comma DHT22 underscore pin comma 0, and then micro delay of 1300. Okay, and then hall underscore GPIO underscore write pin DHT22 underscore port comma DHT22 underscore pin comma 1, and again micro delay of 30. Okay, so this will trigger a pulse, and then over here I am going to give the same thing, GPIO instruct private mode. Instead of this I am going to give it as input. Okay, and then why it is showing something like, just a minute, pin and then mode, right? So GPIO underscore init struct private dot mode, which is equal to GPIO mode output PP. Okay, fine. And after this, now let's move for this pull. Copy this and let me paste it. Pull with is equal to GPIO underscore pull up. Okay, and then hall underscore GPIO underscore initialization. Instead I'm going to pass DHT22 underscore port address of GPIO underscore init struct private, and then micro delay of 40. So we configure the DHT22 pin as an input and wait for 40 microsecond, and then I am going to give a condition. If here Hall GPIO read pin DHT22 underscore port DHT22 underscore pin. So inside, let's start with micro delay of 80. Okay, and then again, if Hall underscore GPIO read pin DHT22 underscore port DHT22 pin. Okay, and after this response which is equal to 1, and after this millisecond which is equal to Hall get tick, which is equal to Hall get tick. Okay, so now while Hall underscore GPIO read pin DHT22 port DHT22 pin address of plus 2 which is greater than, okay, and then inside this I am going to give like which is equal to Hall tick, capital G. Okay, and then return response. So here we will use an if statement to check if the state of the pin is low. If the state of the pin is low, then we wait for another 80 microsecond, and if the state of the pin is now high, then set the value of the response variable to 1. Next, we obtain a tick value in microsecond and save it in the P milliseconds and C milliseconds variable to monitor previous and current tick value. P millisecond, C millisecond is nothing but previous millisecond and current millisecond. Okay, and then after this unsigned integer 8 underscore T DHT22 read again void. So inside unsigned integer 8 underscore T x comma y variable I am going to take. Inside for x which is equal to 0, x which is less than 8, x increment. Okay, so inside previous millisecond Hall get tick. Now C millisecond which is equal to Hall get tick. Okay, now while Hall GPIO read pin DHT22 port DHT22 pin. Now P millisecond plus 2 is greater than C millisecond. So inside, okay, inside C millisecond which is equal to Hall get tick. Okay, and after this micro delay of 40. Now again if Hall GPIO read pin DHT22 port DHT22 pin. Okay, so if the pin is low, then inside y adds of it is equal to tilde inside 1. I'm going to give like okay. Now else 1 left shift 7 to x is equal to hall get tick hall get tick. Now again while inside hall GPIO read pin DHT22 port comma DHT22 pin again millisecond plus 2 greater than C millisecond. Okay, so it will wait for the pin to go low. Now inside C millisecond it is equal to hall get tick. Okay, and after all this return that y. Okay, so inside the DHT read function we read the DHT22 sensor. Inside this function we run a for loop for 8 iteration and obtain the previous and current tick value in millisecond. Then we wait for the DHT22 pin to go high and state keep on accessing the current tick value. Then we shift the bits according to the pin and then wait for the pin to go low state, meanwhile obtaining the current tick value in the millisecond. Okay, and then now we can go for inside the main function. Okay, so all these initialization hall timer base start H timer 1 SSD 1306 initialization. Okay, and inside while if DHT22 start, now inside this 1 which is equal to DHT22 read. Similarly for 2 which is equal to the same thing T. Okay, so now for temp C1 which is equal to same thing. Now temp C2 which is equal to the same thing. Now sum which is equal to DHT22 same thing. Okay, so now check which is equal to humidity 1 plus humidity 2 plus temp C1 plus temp C2. Okay, so now see this inside the while loop. If the DHT22 start function returns 1, then we first call the DHT22 read function 5 times. So the first time the DHT22 sensor is read. It acquires the first 8 bits of humidity and saved it in the variable humidity 1. The second time the DHT22 sensor is read, it acquires second 8 bit of humidity and save it in the variable humidity 2. Similarly for the third time, fourth time. Okay, and then the fifth time the DHT22 sensor it read, it acquires all the combined readings as a sum and saved it in the variable sum. So now inside we can go for a condition check which is equal to sum. Okay, so if this condition is true, then inside another, if temp C1 is greater than 127, then Celsius, which is equal to, I'm going to mention the float type, okay, and then temp C2, which is divided by 10 multiplied by minus 1, else Celsius, which is equal to, again, float inside this temp C1 left shift to 8-bit or temp C2, which is divided by 10. Okay, so here we check if we are getting accurate reading, which happens when the value held in the variable sum, which is equal to check. Then we move ahead and obtain the temperature reading in Celsius and save it in the variable called temp Celsius. Okay, both positive and negative temperature readings are captured through an if-else condition. Now after this, temp Fahrenheit, which is equal to temp Celsius, which is multiplied by 9 divided by 5 plus 32. Now humidity, which is equal to float and then humidity 1 left shift to 8 or humidity 2, which is divided by 10. Okay, so now we are going to print the thing. Okay, so SSD1306, set cursor 0, 0 and then integral, which is equal to humidity. Now decimal, humidity, which is multiplied by 10 and then integral, okay, which is multiplied by 10. Now printf, I'm going to pass the string %d point %d percentage and percentage. Okay, just to print the thing in the correct order in the print thing, that's why. Okay, and after this SSD1306 write string comma font 11 cross 18 comma 1. Okay, so now SSD1306 underscore set cursor 0, 20. Okay, so now on condition, if temp Celsius is less than 0, then integral, which is equal to temp Celsius, which is multiplied by minus 1, and then temp C underscore decimal, which is equal to temp Celsius multiplied by minus 10, and then temp C integral, which is multiplied by 10. And now printf string comma %d dot %d and then c, and after this integral comma temp c decimal. Okay, so after this we can go for else condition. Okay, so in this condition temp c integral which is equal to temp Celsius, and here underscore. Okay, and after this temp c decimal temp Celsius which is multiplied by 10, and then temp c integral which is multiplied by 10. Okay, so now s printf string comma %d dot %d and then temp c integral comma temp c decimal. Okay, so now after this STM32 write string comma font 11 cross 18 comma 1, and then STM32 set cursor to 0 comma 40, and then again if temp Fahrenheit which is less than 0, then inside temp f underscore integral Fahrenheit which is multiplied by -1. Okay, and then temp f decimal which is equal to Fahrenheit which is multiplied by -10, and then temp integral which is multiplied by 10. Now s printf string %d dot %d f, and over here temp f underscore integral comma temp f underscore decimal. Okay, now let's go for else condition. So in else condition temp f integral which is equal to temp f Fahrenheit temp f decimal which is equal to temp f Fahrenheit which is multiplied by 10, and then temp f underscore integral which is multiplied by 10. Okay, and then again s printf string comma %d dot %d f, and then comma temp f integral comma temp f decimal. Okay, after this STM32 and underscore write string font 11 cross 18 comma 1 and then SSD 1306 update screen. Okay, and after all this, let end it with the delay of just 1 second. So that's all about the program. Write the same program and make the connection as I explained in the slide. You will get the output in the OLED display.